Ever wondered why even light, the fastest thing in the universe, can't escape a black hole? It's a mind-bending question, and the answer lies in the very fabric of space-time. Let's dive in. First, forget the idea of a black hole being a cosmic vacuum cleaner. It's not about sucking things in. It's all about gravity, but not just any gravity. We're talking about an insane amount of gravity. Imagine taking a star many times more massive than our Sun and crushing it down into a space smaller than a city. The result is an object so dense that its gravitational pull becomes overwhelmingly powerful. This is where Albert Einstein's theory of general relativity comes into play. Einstein showed us that massive objects don't just pull on other objects, they actually warp or bend the fabric of spacetime around them. Think of spacetime as a stretchy rubber sheet. If you place a bowling ball on it, the sheet dips down. Now roll a marble nearby. It doesn't travel in a straight line. It follows the curve created by the bowling ball. That's essentially how gravity works. The Earth is just rolling along the curve in spacetime created by the Sun. A black hole takes this to the absolute extreme. It's not a bowling ball on a rubber sheet, it's more like a bottomless pit. The curvature of spacetime is so intense, so deep, that it essentially closes in on itself. Now let's bring light back into the picture. Light, made of particles called photons, always travels in a straight line. But in the presence of gravity, that straight line follows the curves of spacetime. We've actually observed this. During a solar eclipse, we can see that the light from distant stars appears to shift as it passes by our Sun, because the Sun's gravity bends its path. So, what happens when light gets near a black hole? As it approaches, it has to travel along this extremely warped spacetime. There's a point of no return called the event horizon. This isn't a physical surface you can touch. It's a boundary in spacetime. Once light crosses the event horizon, the curvature is so severe that all paths leading away from the black hole are curved back towards its center. Imagine you're in a river that's flowing faster than you can swim. No matter how hard you try to swim upstream, the current will always carry you downstream. For light at the event horizon, it's a similar concept. The current of spacetime flowing into the black hole is faster than the speed of light itself. All possible paths, even for light, lead only inward. Every direction you could possibly point a flashlight, the light would end up at the center of the black hole, a point called the singularity. So, it's not that light gets tired or slowed down. It's still moving at its constant speed, about 300,000 kilometers per second. The problem is that the space it's moving through is being pulled into the black hole faster than the light can move away. The very geometry of space is trapped, and since light must travel through this space, it's trapped too. That's why black holes are black. They emit no light of their own, and any light that gets too close is captured forever, unable to escape and reach our telescopes. It's a perfect trap, governed by the fundamental laws of our universe. It's a place where gravity wins the ultimate battle against everything, even light itself. It's a truly fascinating concept that pushes the limits of our understanding of physics. What other cosmic mysteries boggle your mind? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into the cosmos, don't forget to like and subscribe for more deep dives into the universe. See you next time.